All right, in this lesson, I'll introduce the PD melt method, which basically works essentially as the reverse operation to a pivot table. It essentially takes an aggregated data set and then converts it to a tabular format. Let me show you what I mean. I'm going to use my read CSV method here to import a new CSV called quarters.csv. And for now, I'm just going to save it in a variable called sales, and I'm just going to output the entire variable right here. It is a fairly small data frame, but here what you can see is we have a data frame with 10 salesmen. They're listed right here in the very first column. And to the right, we have essentially their revenue numbers, let's say, for each quarter throughout the year. So here is how much Boris made in quarter 1, quarter 2, quarter 3, quarter 4. Here's how much Bob made, and so on and so forth. Let's say that we want to convert this to a more tabular data structure. We basically want it to say Boris, followed by the quarter, followed by the revenue. So we basically want to take this information and essentially create one line for each of these data points right here, one line for each of these data points for Bob right here, and basically move this information from the columns to another single column that's going to represent that information. So again, super hard to describe in words, but let's take a look at how it works in practice. So I'm going to call the melt method directly on pandas, open my parentheses, and the very first thing here, as you can see, it's expecting a frame, and our frame is being stored in sales. So I'm going to put sales in here. And then the parameter that I want to look at here is ID vars. Basically, this is going to accept an argument of, essentially in this case, a single column that's basically going to indicate what's going to remain as the column that's going to be preserved, essentially. Now, the values here are going to be duplicated, but this is going to be the column that's going to be kept in place. So basically, what we want to do is we want to keep the salesman, because for these columns, Q1, Q2, Q3, and Q4, those are the columns that we basically want to destroy because we're going to take their values and store them in a brand new column. So what I'm going to do is for that ID vars parameter, all I'm going to do is give it the argument of salesman, which is the name of this column right here. So what it's going to do is it's going to keep these values. Of course, it's going to create 4 copies of each, one for each of these numeric values. And let's take a look at what we get. So right below here, you can see that we've created a new 3-column data set. And you can see that Boris is now going to remain because that salesman column is what we told it to keep. But now we have this new variable column, and what this variable column represents is the value that was stored in each one of these columns. So you can see as I start here, we begin with Q1, and then we move on to Q2, and Q3, and Q4, and so on. So predictably, if I take a look, for example, at me, Boris, in Q1, I had 602,908, and that's the value that's listed right here for Q1, which has been moved right here into this new variable column. And for example, for Q2, I have 233,879, and that was on a single Boris row in this original data frame. But now if I go to Boris Q2, you can see that there's that value, but now it's going to have its own separate row in this brand new data frame. So basically what we've done is essentially take these columns, these values right here, and basically condense them into a single variable column. So these values right here are going to represent my old column headers. Whoops. And then the values are just going to be the reformatted, aligned values from those columns. Now, the default that Pandas is going to do is to call this column variable. That's going to represent our old column headers right here. And then call this column values, which is basically going to represent the values here. And we can basically change that very easily through 2 other parameters. We have the var name parameter, which is going to be basically this variable column that's being generated. So if we take that parameter and we provide it a new argument, this is really the quarter. This is basically specifying the name that's going to appear in the column that's going to serve as the collection of all the column headers right here. So we want that to be quarter. So now you can see salesman is appearing, and this represents our quarter, which is good. And finally, we want to give another name to this value column, which is basically going to be the default column header for all of the actual values that have been realigned from this original data frame. And that's available in a value name parameter. We can see it right here. So instead of having value, I'm just going to change that to be revenue. So now you can see we've created a new 3-column data frame. It looks different from the original one, but it's basically storing the exact same data, just once again, which is the central theme of this whole module, just realigning the data, pivoting it, looking at it from a different angle, from a different perspective. Nothing has changed technically. We haven't even, aggregated or formed any kind of calculations here. We've just taken these columns and condensed them into a single column called quarter, and then moved the corresponding values for each person into their proper row, where we're now going to have 4 rows for every single salesperson, one row for each quarter for every single one of our 9 salespeople here. So you can see we have 9 total people. We start at 0 and we go to 8. So 9 total people times 4 rows, 1 for each quarter, is going to be 36 total rows. So here in this data frame, predictably, we're going to have 36 total rows. That's going to be 9 salesmen times 4 quarters for 36 total rows. So again, the melt method is basically how we reorient and reorganize our original summarized data frame into a more tabular structure.